Let's talk about the difference between folic acid, and I'm talking about the synthetic version of vitamin B9, as well as folate, the natural version. Are they the same? So many women, wow, when they're pregnant, they start taking a prenatal that is just loaded up with this synthetic folic acid. And there's a lot of data to show that that can help prevent things like neural tube defects, which is an incomplete closure of the spinal column. And so it's true, it does do that. But with more and more people recognizing that they may have a mutation with a certain gene that relates to B9, I think we should talk about it. There's a very common problem with a gene that is called MTHFR. It involves an enzyme in converting folic acid into the active form so your body can use it. So if you have a problem with this gene, your ability to get this active form of B9 is greatly inhibited. And if you end up taking this synthetic version, what's called folic acid, you can have a lot of problems because it can accumulate as unmetabolized folic acid. Now, it probably is not going to become a problem unless you take large amounts. But the fact that if you have this mutation, you're going to be deficient. So there's this delicate balance of getting just the right amount of this B9. Because here's the thing, B9 actually does a lot of things. It protects against the initiation of cancer because B9 helps to protect the DNA against problems with the code. And if you have just the right amount of B9, it can protect this damage within the DNA that can potentially then lead to cancer. B9 also is involved in the initiation of new cancer cells. That sounds like it's kind of conflicting. On one hand, it prevents the initiation of new cancer cells, but on the other hand, it can actually help grow this cancer cells. But based on the data that I read, it's really when you have way too much of this folic acid. So this complicates things because with this mutation, you need more than you normally should have, yet you don't want to get too much. So the solution to this problem is to take a type of B9 that doesn't have to be converted, okay? It doesn't require this enzyme. So in other words, this mutation is a no issue. Why? Because it's ready to be used and can be easily absorbed in the body. And that is called methylfolate. And there's other long names for it, but basically it's a type of B9 that's easily absorbed and it doesn't require these other enzyme reactions like the synthetic folic acid. Now, sometimes you'll hear reports and studies that show that regardless of this mutation, you still need to take this synthetic folic acid to prevent neural tube defects because there is no studies comparing this synthetic folic acid to this methylfolate. And that's true. And they're not going to do studies because to do that on humans, right, it's too dangerous. It's too unethical. So it's not going to be done. So you're just going to have to use common sense. Even if you compare these two versions of B9, it's going to be more effective for you to get enough B9 in your blood using the methylfolate version. The other thing is if you have this mutation, there's some studies to show that if you're taking way too much synthetic folic acid or the mother's taking way too much, that can increase the risk of autism by a factor of 17x. And this synthetic folic acid cannot fix this mutated gene. In fact, it can block the natural version of folate and potentially increase your risk of getting cancer. So that being said, the question is, how do I make sure I'm not getting too much of this synthetic version? Well, unfortunately, it's put in our food supply. It's as part of the fortification for all cereals, okay, that kids eat, also adults. It's used in all the breads, the pasta, the cereal, the crackers, the biscuits, the energy drinks, a lot of the synthetic vitamins, as well as fortified nutritional yeast. That's why I always recommend to get the unfortified version of that. Even more importantly is to start to consume the foods that are high in this natural B9, which is consuming more dark leafy green vegetables. The last point I want to bring up is that if a person has this genetic problem and they're taking a lot of folic acid to prevent, let's say, anemia or some other problem, what can happen is they can end up camouflaging a B12 deficiency. because B9 and B12 work together. And that can create problems with an increase of something else that I want to kind of just summarize very simply. It's called homocysteine. Homocysteine is a bad compound that can increase your risk of getting heart attacks and strokes. And homocysteine also affects the inside of the artery, the endothelial tissue. It inhibits this nitric oxide that then can cause you to have high blood pressure and create all sorts of problems. But it's not just a problem inside your heart. It can affect other areas as well. Because if there's a diminished nitric oxide, you can end up with erectile dysfunction.